Hello, everybody. Here we are, 3.1 tangent ratio. This is the first lesson of Math 10. This is from the chapter Right Triangle Trigonometry. You recall a right triangle is a triangle that has a 190-degree angle. And yeah, we use this in the Pythagorean theorem. And basically, this is just ways of calculating angles and side lengths. We use the properties of right triangles and similar triangles in trigonometry to figure that out. It's a branch of math that studies the relationship between angles and the lines that form them in triangles. And it kind of first developed its use in astronomy and in geography. So today we use it for surveying, navigation, engineering, construction. I'm going to sneeze. Excuse me. Let's get started. The first thing that we have to figure out and have to recall and have to learn is labeling the sides of our triangle. So here's a right triangle. Let's use this angle right here. And we use we call this angle theta. So theta, and that's just like a Greek letter, looks something like that, a little circle with another circle in it. And this is sometimes called or often called our reference angle. So it's from this angle that we would label the other side. So it's still true that the longest side that's opposite our right angle is called the hypotenuse. And now the side that's opposite, so directly across from our reference angle, is called the opposite. And the side that is touching our reference angle and isn't the hypotenuse is called the adjacent. So that's really important. The tangent ratio compares the length of the opposite side to the reference angle to the length of the adjacent side to the reference angle. So tangent of angle A equals the length of the side opposite angle A to the length of the side adjacent to angle A. So, it does depend if we're using this as our reference angle right here. The what's opposite that is different than if we're using this as our reference angle. Then now this is the opposite and this is the adjacent. So it does matter, and that has to be something that we can keep track of. And remember that the hypotenuse is always the hypotenuse. Also, I'm at home recording this. If you hear my cat, that's the way it goes. So you can use the tangent ratio to, I'll show you this, determine the measure of one of the acute angles when you have the lengths of both sides. So let me show you what that looks like. So if we have a right triangle like this, say we know the length of this one, this is 10 centimeters. Say we know the length of this one is maybe 12 centimeters. We can use this information to find out this angle, an acute angle, so less than 90 degrees. And we can use it to figure out that angle, the angle that's less than 90 degrees. So we can use either of those pieces of information to find out the angles. And number two, we can determine the side length if the measure of an acute angle and the length of one of the sides is known. So I'll show you what that looks like. So we need two pieces of information basically to figure out the third one. So if we know, say, the length of this is 12 centimeters, and we know this angle right here is, 30 degrees, we can use that to figure out this side length right here. So if we have the angle and one of the sides, even if we had this angle right here, say this was 60, we could use that to figure out the other side. Okay, first bit is determine each tangent ratio to 4 decimal places. You need to make sure that your calculator is in degrees. So this one is a pretty kind of straightforward calculator question. Let me move this over. You just need to do, let's clear all this. Oh, it doesn't really matter. Clear all. There we go. Just need to press tan 30 and you get 0.77. I'm going to round it up, 0.77. 0.5774, 0.5774. So I did it to 4 decimal places, so I rounded up. Next one, let's just do, and I make sure I'm in degrees. You see right there. Let's go tan 12. So that's 0.2126. Okay, so that's just a kind of like straightforward calculator question. If you have the degree and you're looking for, this is just the ratio. We'll see a little bit later how we use that to find out other information. If you determine the measure of an angle, you're always going to use the inverse operation. So whenever you're trying to, if you're looking for a length, you use tan. If you're looking for the angle, you're going to use the inverse. So it might look different on your calculator. Maybe you're going to use like a second function button. I'll show you how it looks on mine. So if we go back, I press function on mine. I can get the tan to the -1 is the inverse. And then I can put in, what was it, 0.6. And I'll get the angle now of tan. So let's round up 30.96. I'm going to round it up to 31 degrees. So I can show this as tan to the -1 equals 31 degrees. Let's do the next one. I also feel like my I don't know why I draw my T's like that. It sometimes looks like an F, but it's a T, I promise. Let's show the next one. Sorry. 0.1584. So function, tan inverse, 0.1584, 9 degrees. There we go. So tan B equals 9 degrees. Okay, let's do the next few, and I'm going to show you how I would set this up and how you can remember what you're going to, if you're going to be multiplying or dividing. We're going to kind of set it up as an equivalent fraction. So determine the measure of the indicated sides, express your answer to the nearest tenth of a centimeter. So we have a side length and we have a angle, and we can use the tan of the angle 40. That's going to equal, so tan equals opposite, remember, over adjacent. So we don't know the opposite angle. Currently, the opposite is the mystery to us, the x, and that's over the adjacent, which we do know it's the side that's touching our reference angle, and we can set it up like that. Now we can cross multiply and divide. So maybe I'll show that in a different color. This can be over 1, and you could think about cross multiplying and dividing. Our equation now is going to look like this. Tan 40 times 5.4, I'm just going to use a dot to show our times, equals x, kind of like times 1. So now let's figure out tan 40 times 5.4 is going to give us our answer. So let's go here. Tan 40 times, I want to clear that. Tan 40 times 5.4 equals 4.53. So x equals 4.53 centimeters. We were looking for a side length, as you recall. And as a final question, I always try to get us to ask ourselves, does that make sense? Yeah, I would say that makes sense. You know, it's not like drastically longer than 5.4. Seems like it might be a little bit shorter, and I think that is a completely reasonable looking answer. Let's do the next one. We have tan, this is our reference angle right here. If we're doing tan 61, that equals, remember, opposite over adjacent. We have the opposite, 14.2, and it's the adjacent that we don't know. So now when we cross multiply, it's going to end up looking like this. Tan 61 times x equals 14.2. And it's x we want by itself. It's currently being multiplied by tan 61. To get it by itself, let's divide each side by tan 61. And this would just become 1. And we're left with x is going to equal 14.2 divided by tan 61. So let's do that. 14.2 divided by tan 61 equals 7.87. So x, 7.87, looks like centimeters. ask ourselves as a kind of final step, does that make sense? I would say, yeah, that does make sense. Looks like, it's in a reasonable proportion to 14.2 centimeters. It's a little bit shorter. I think looks like a reasonable answer. I think you could say, yeah, I probably did that question right. So let's go on to the next ones. Number 4, determine the value of each variable to the nearest degree. Okay, they want the nearest degree, so let's round up. State the tan ratio and like the tan angle. So when we say tan ratio, it's kind of just like the first step. So we're looking for tan theta equals opposite. So here's our angle, a reference angle. 6 is opposite over the adjacent side, the line that's touching our reference angle, but isn't the hypotenuse, 8.2. So here, this part right here is the ratio. Okay, let's do the next part. And now we can figure out the angle. You can, I think, like convert this first, but I like to do it kind of all as one step because it might be like a long decimal. And I think it's more exact to kind of keep it this way. So I'll show you what that looks like. So I would go tan, let's clear this, tan 6.0 divided by 8.2, close our brackets, and we get, we're looking for the angle. I needed to do, my bad, I need to go function. See, look, I said that doesn't make sense. That doesn't make sense as an angle. I've obviously done something wrong. The angle is going to be, more like 30. And I got this like long decimal. So what I'd forgotten to do, you'll see, is do the inverse. So inverse tan 6.0 divided by, there we go, 8.2, close our brackets, equals 36.19. So 36, so the tan theta equals 36 degrees. And let's do the next one. Now we have tan A equals the opposite, the one that's across from it. Oh dear. Oh dear. 24 over the adjacent one. It's touching our reference angle, but it's not the hypotenuse. So over 15. And now let's do that. Again, I'll remember this time to use the inverse. 24 divided by 15. 57.99, let's round it up to 58 degrees. So tan A equals 58 degrees. And there you have it. So if you're looking for a degree, remember to use the inverse operation, as I did not. But also, remember to check your answer at the end to ask yourself, does that make sense? That's what I did. I saw that I got an answer that didn't make sense or I wasn't expecting. And then I realized what I did. So let's do these last 2 word problems. Mary wishes to determine the height of a tree in her yard. Interesting. Who knows her motivation? But she measures the angle of the elevation to the top of the tree to be 25 degrees at a point 20 meters from the base of the tree. So here is the words, but we have a nice diagram. So she's determined this angle right here is 25 degrees. And she knows that this is 20 meters. So she's here. She's 20 meters from the tree. She's determined this angle to be 25. Okay, so we're looking for a length. So we're saying that tan 25 equals, we have adjacent. We have the length that's touching our reference angle, but it's the opposite. It's the h that we don't know. And now we can cross multiply. So that's tan 25 times 20 equals h. And let's just do that in our calculator. Tan 25 times 20 equals 9.3. I think that's enough, 9.3. So h, or the height, equals 9.3 meters. Does that make sense? I would say that does. That's like a, reasonable height, kind of maybe like half of the distance. It's not like much larger. We kind of expect it to be a little bit less than 20, but not drastically shorter. I think that makes sense. Hello, I think I got cut off. But our last question, Matt is 1.65 meters tall and his shadow is 1.43 meters long. Determine the angle of elevation of the sun to the nearest degree. So we have a word problem. They've drawn us a nice picture, which I think is really helpful. We know the side lengths, and it's this angle that we're trying to solve for. So we're trying to find tan of the angle equals, let's set up our ratio, the opposite. So the length that is directly across from our reference angle, 1.65 over the length that's adjacent, so it's touching our reference angle, but is not the hypotenuse, 1.43. And since we're trying to find an angle, we need to use the inverse. So let's go, 1.65 and 1.43. Clear. 10, 1.65 divided by 1.43. That equals 49. I'm going to leave it at 49 degrees. I don't think we need to round up unless it asked me to the nearest degree. So 10 theta equals 49 degrees. There you go. And I think that makes sense. I mean, it seems like a kind of, greater than 45 degree angle. And I would say that makes sense as a final answer. Okay, that's it. I'll let you know what textbook questions I want you to do.